In this example, we're asked to estimate the area under the curve between 0 and 4 using an upper sum, a lower sum, the midpoint rule, and with 2 rectangles and then 4 rectangles. So let's begin using an upper sum and 2 rectangles. So we're going to split this from 0 to 4. We're going to split it from 0 to 2 and from 2 to 4. Now, because we want an upper sum, we're going to take the higher part of the function, and because our function is increasing, that is going to be at the right value on our interval. And in this case, our d of x is equal to 2. So we're going to have 2 times f of 2 plus 2 times f of 4. 2 times 2 squared is 4, plus 2 times 4 squared is 16, and we have 8 plus 32, which is 40. So our estimate for an upper sum of 2 rectangles is 40. So let's see what would happen if we were to move to 4 rectangles. So I'm going to split this in half again. So we now have 4 rectangles. And again, we're using the right part of our interval because it's the upper sum of our value is increasing. And this time our dx is going to be 1 because we split this up in intervals of 1. So we have 1 times f of 1 plus 1 times f of 2 plus 1 times f of 3 plus 1 times f of 4. So we have 1 times 1 squared, which is 1, plus 1 times 2 squared, which is 4, plus 1 times 3 squared, which is 9, plus 1 times 4 squared, which is 16. A total of 30. So now let's try and do a lower sum. So a lower sum with 2 rectangles. We're going to split this up into our 2 rectangles. And because it's a lower sum, we're going to be using the cutoff on the left of our interval since our function is increasing. So our dx is going to be going back to 2 because we split it up in intervals of 2. And we're going to have 2 times f of 0 plus 2 times f of 2, which is 0 plus 2 times 2 squared, which is 4, 8. So our estimate is 8. Now let's do a lower sum with 4 rectangles. So we're going to split this into 4 rectangles again. And a lower sum. Our dx is again 1. So we have 1 times f of 0 plus 1 times f of 1 plus 1 times f of 2 plus 1 times f of 3. F of 0 is 0 squared, so that's 0. 1 times 1 squared is 1. 1 times 2 squared is 4. And 1 times 3 squared is 9. So we get a total of 14. Okay. So now let's use the midpoint rule. Let's flip this back up into our 2 rectangles, and this time instead of using the function at the left endpoint or the right endpoint, we're going to use it as the midpoint. So our midpoints are 1 and 3. Our dx goes back to 2. So we have 2 times f of 1 plus 2 times f of 3, which is equal to 2 times 1 squared, which is 1 times 2 is 2, plus 2 times 3 squared, which is 9, which is 18, for a total of 20. So now let's use the midpoint rule with 4 rectangles. So again, we're going to divide this into 4 rectangles. And take the midpoint. Oops. Take the midpoint to be the top of the rectangle. Okay, so now we've got dx of 1, we have 0.5, I'm sorry, we have 1 times f of 0.5 plus 1 times f of 1.5 plus 1 times f of 2.5 plus 1 times f of 3.5. And that gives us f 1.5 is 0.25, f 0.5 is 0.25, f 1.5 is 2.25, f 2.5 is 6.25, and f of 3.5 is 12.25. Add all together for a total of 21. Now let's say that I told you that the actual value of the area under the curve here is 21.33, which it is. So what can we learn from the upper sum and the lower sum? As you can see, the upper sum always gave us an area greater than the true area. The lower sum always gave us an area less than the true sum. And the midpoint generally gave us a pretty good estimation. And as you can see, as you move from 2 rectangles to 4 rectangles, you get closer to the actual value, and this is true for all of these. 30 is closer than 40, 14 is closer than 8, and 21 is closer than 20.